In this AI Masterclass video, you'll go from a complete beginner to an expert about AI. This video is going to be about knowing all the concepts, all the vocabulary, understanding how AI works. So that then when you use Claude, ChatGPT, or all these models, you can take the most out of it and get the best results for yourself. But before doing that, you first must understand what is AI, how it works, and all the vocabulary needed for you to use it correctly. So let's dive straight in.
The AI that matters every day.
So these are the whole things we'll go through. So let's get straight in. So most people when they say AI, they usually mean another thing. And that other thing is an LLM, a large language model. A large language model is like Cloud Opus 5, Sonnet 5, ChatGPT 5.6, Gemini 3.6 Spark, or Kimi K3 for example. And a large language model is just a program that has read an enormous amount of text, of data. It has been trained with an enormous amount of data. And it learns the pattern in how language works. So a large language model, when you give it a text, a prompt, it doesn't read like us, that it reads like an LLM predicts the next token over and over again. No, it doesn't read like us. It divides everything into tokens that are small pieces. Like for example, in this case, in this phrase, it will read it like this. An LLM predicts the next token over and over and then a dot. It's not like it doesn't have like every 4 words or every 3 letters. It doesn't have that parameter, but usually it's like 100 words equals 75 tokens, more or less. First, let's differentiate what it is and what it isn't a large language model. It is a next word predictor at a massive scale because every word it says, it gives you the response, it predicts the next word you are going to say and his answer. So it basically predicts what is the most likely word that's going to come next. And because it has this massive scale of data that has been trained, it's able to do this. And it's brilliant. The best things it can do is drafting, rewriting, explaining concepts, especially concepts that has a ton of data. Because if you ask it about a concept, a book that it's not even in Google and it doesn't have the data when it was being trained, then it cannot answer correctly and it hallucinates. That's when people say that it lies, but it cannot lie because if it lied, it implied that it know the truth. But what happens is that it does not know the truth, so it hallucinates. And then a fast, tireless thinking partner. It's like having a partner that you can give it, you can ask anything, tell it to do something, and it's tireless. It never rests. It's faster, and even with the strongest models that we have right now. And what it is not. It's not conscious, it doesn't want anything, it cannot think by its own. You are the one that gives it the instructions and what it has to do, the tasks. It's not a database of look at facts because after the training then it doesn't know about the current. For example, if you ask it about how's the weather today and how many degrees, it does not know about it because it has only the data that has been trained. Then after training it, that's when they release it to the public, it doesn't have the actual data. But for that, they now have put a web search engine that you may have seen inside Claude or ChatGPT. That it's basically something to let the model, the large language model, search in the internet so it has the current actual weather, for example, information. It's not always right, as I said, even when it sounds confident, it may a plausible, confident answer, but it's not always right because it can make mistakes as humans. It doesn't make a ton of them, but it also depends on how you use it, what parameters you put, how you explain yourself, and how you tell it to perform a task. And also about the concept that you ask it about, if it has a ton of data or just a small piece. The next thing is about differentiating what artificial intelligence, large language model, or machine learning is, because most people mistaken that these concepts and don't know exactly what it means, what differentiates them. So let's talk about it. Artificial intelligence is just a smart machine, an intelligent machine behavior. We had it before, it's not like now in 2024 when ChatGPT was released. It was before when there were these computers that could recognize images and tell you what it was. So artificial intelligence is, just bear in mind that it's a smart machine behavior. Then we have machine learning, that is that smart machine behavior that has learned from examples, from the ton of data that we talked about before, from all these example books, internet, all the data that it costs millions to train that large language model. Because a large language model is just a machine learning focused on language, so that you can write it on plain language and it can understand you. With all these three different concepts, AI, LLM, and machine learning, all this doesn't mean that AI learns, because that's a different thing. Because first we need to distinguish between hand-coded AI and machine learning. So first, hand-coded AI is just an AI that has rules written by humans directly, instead of learning from the ton of examples of data it has been given. So it basically has rules. It's more like instructions. A human tells it what to do exactly, and it's much more predictable because you have given it the rules. Then we have machine learning, that it's what learns from patterns from all the data. It analyzes all the patterns from the huge amount of data it has been trained, and that's why it can predict the next word. And it improves over time without being explicitly programmed for each task. So the more you use it, the more it gets better, but not instant, just in the training phase that we'll talk about it later. So just machine learning, it learns patterns from data. And then hand-coded AI, it has rules written by humans. So let's put an example. For example, if we use these two, like the hand-coded and language machine, we can put an example of movie recommendation system. For example, the hand-coded AI, it follows the rules as we said. So if a person like movie A, it will like movie D, because if that was a rule, then it will answer this. But then we have the machine learning that we said that learns from patterns from the data, patterns from data. So if you ask it about a movie recommendation subject, it learns from observing the millions of people that it had in the data that it has been trained. So the key difference is that the hand-coded AI follows just the rules, and the other one, it uses the data, the patterns, it observes all this to give you the response. So for example, learns from observing millions of recommendations of movies, whereas the hand-coded AI is just tell you, if he like B, he will like C, or he like movie A, he will like movie D. Another classic example is that hand-coded AI uses a lot of rule-based systems like chess, so it's used for chess. It's a great example because it has all these rules and you can predict, it's predictable what it can do, because it doesn't have an infinite amount of responses. It can only do some things following the rules of chess. Then from the machine learning, you have like the data driven models like Claude, ChatGPT, all these kind of models. That one good example is like images. It can recognize images. For example, if you it has been trained with so much data that can recognize an image of a cat and distinguish it with an image of a dog or of a crocodile, for example. so it can adapt to the situation by observing the millions of data and patterns it has been trained, whereas the other one is just rule-based. Now we're going to differentiate between models and apps. An app is like Claude or ChatGPT, for example. It's like the whole infrastructure. Then the model is like inside Claude we have Fable 5, Sonnet 5, Opus 5, Haiku 4.5, or inside ChatGPT we have the ChatGPT 5.6 Sol, 5.6 Terra, 5.6 Luna. These are the models, and then the app is like the whole Claude. Claude doesn't change, but they keep releasing new models, like now the Fable 5 or the ChatGPT 5.6. So to make it clear, a model is like a brain, a rat-trained brain. If we put the example of a car, it's like the engine with how it goes. It needs the engine to work the car. It just you give it text in and it gives you text out, and this is how everything works. Then the app is like how you wrap the whole engine like the car, and it has the chat, the window, the login, the memory, the files, the conversations, the projects, everything you can do inside Claude or ChatGPT or any app. And then the model is just like the engine. So that's why if you have heard of it, you can use like the car of Claude, but then instead of using an engine of Claude like Sonnet 5, you put it a free local model, and then it improves it because it hosts the whole car as Claude, but you just change the engine. But we'll talk about it later. This just bear in mind like app, bear in the mind that it's Claude, ChatGPT, and model are like Sonnet 5, ChatGPT 5.6. Now the difference between tokens, models, and context window. Tokens are just what I said earlier, what are chunks of data that the AI, the large language models, use to process, generate responses and everything. It's like if we put an example like with money that you can have physical or now pay with a credit card. So tokens is just like the Bitcoin, it's like a different thing. So in English it's more or less 100 words equals 75 tokens, but it varies. It may be just a whole word, then it's just a dot. So it's what AI uses to generate, produce, to read through text and everything. It's like their language model usage. Then the window, we have like the memory, what AI remembers about you, what for example Claude remembers about you, what you have told it in that conversation in that same window. It has the memory, and when you have filled it up, it's just like what it appears the context that you have left. So when it's empty, you can have all this memory, but then when you have been using it a lot and it's full, then it won't remember stuff from the beginning, and that's where you have to compact or start a new chat. Then there are the instructions that when you create projects or just in a chat, you tell it what the instructions that you want it to follow. You can upload documents like PDF, docs, documents of Google, HTML, but the best ones for AI is markdown files, is .md, because this is just raw text and it's the best one, and it is the one that it works perfectly with AI and it uses the less tokens as possible. Whereas a PDF or an HTML file is the one that burns most of the context window, most of the credits, because it has all the visual stuff, not just the text. So the best thing for just text, use markdown files. You can search in the internet to convert from a PDF to a markdown file, or you just tell it the AI and then start a new chat and upload that markdown file. Then you can have the conversations with any model, or you can create agents and all this stuff. And then it replies back. You can see how it does it. It may ask you questions that appear in the chat, and you have to select one, and it replies, and if it has done like an artifact, it appears, it has a web search tool, and a lot of more things. So now we are going to look at why a long chat forgets, because maybe you have already tried and you have burned all the context window and then it starts forgetting things you said at the beginning and you get frustrated. So why does a long chat forget? When chat grows past the window size, then it's when it's starting to forget, but not just when it goes through the limit. Just when it's like 40% left, it even starts forgetting things. So you have to bear in mind that when you hit like 40% left, then you have to either compact or then send it to give you a resume of what it has done and what it has to do. So you start a new fresh chat, or compact that what happens is it compacts the whole conversation, and then it gives like the prompt that the other way, like it has like a prompt that when you send it another chat, and it has this all the conversation summarized, so you have context a window again. It's like fresh. It just burns like a few tokens, and that's it. It compacts everything into a small like prompt for him. It does it, you just have to put /compact, and that's it. Another reason is that older tools drop off the edge. What it means that the oldest facts that you gave them at the beginning of the conversation is what it starts to forget, is the first thing it starts to forget. Then when it happens that the models can't see those stats or facts anymore, then it's correct. That's why it forgets, because if it doesn't have it, if you have compact and it doesn't appear, or if you have started a new chat that it doesn't have all that facts that it had at the beginning of the conversation. And you fix it by just telling it again the details, but that's just a way that it takes a lot of time, because you have to re-explain yourself, and even more if you have to change between model. So that's why it's great to have like a second brain. They call it an operating system, that is just a folder in your computer local, where you have all the context, all the things about you that you want AI to know, all the projects divided by folder, files, everything it does inside that second brain, with markdown files that tell Claude where everything is, so that it knows how to find it fast, and also stores all your skills. So that's one thing that you should know when you have started using AI. So now the difference between the two phases that AI models, LLMs, go through: training versus using. So this is a life of a model, of a large language model, like for example Fable 5. It starts with the training. Month of compute that costs millions. They put all the data, all the facts, all the things it trains, all this training. It's the part that it's most expensive and that it takes more time. So this is the biggest part. It costs millions to generate and train with all the data, so that when you use it, it knows, you can ask it to do anything. And we have these so intelligent models like Fable 5, ChatGPT 5.6, Sol, and these kind of models. The bigger one, the more that has been trained, and has been trained better because it learned from the other one and improved over time. Then we have the model frozen. It's like when it's frozen, that it doesn't have the training that it had in the training phase. In this model frozen phase, its weights are locked. They don't put more data to training, and it doesn't update. It just froze, like the name, model frozen. It just froze like right there. And then it becomes the inference. That's when you can messages and you can reply it faster. The inference is when they put like the large language model, like when they release Fable 5, for example, and you can use it. but before it went through that training, and then they froze it, and then the inference so that you can use it. And they repeat that inference forever. So that model never changes. It doesn't learn from your conversation in real time. No, that doesn't happen, because the only part where it learns is in the training phase, and it's the first one. Then they froze it, they inference, so you can use it, and it repeats that inference forever. For example, one of the first models of Claude, it was like sonnet or haiku, and you can still use haiku, and it's not like Fable 5, because it doesn't learn from the conversations, it just learns from the training phase. But they use that conversations to train another model. Like, for example, they have Opus 4.8, like they had a month before. They have trained it, they have froze it, now it's public access, you have to pay or you have Claude, and you can use it. And you can use it forever. But then from the conversations, they use all the data from the people that are using it to train another model that is strongest. So that's why they cannot go backwards, they go forward, because they kept training those models. And now they train another model. They froze it and decide to call it Fable 5. Now you can use it, and now they are now you can use it from months, and it's like the same model, it hasn't changed anything. But then we might, now with all the data, with these months or months that we have had Fable 5 and hundreds millions of people using Fable 5, they have all this extraordinary data to put it in the training phase. So now they train a model, they froze it, and they might call it, for example, Fable 5.2, so that it's better, because every time every new model they release is better from the other one. And now you can have public, and then they will probably train it for maybe Fable 6, that it's even much bigger the gap between Fable 5. And that's how they keep releasing new models. And as you may see, all these companies keep releasing every week, every month. We have been with a ton of models. But it's great for you to know how the life of a model, like all these four phases, because most people think that when in the inference phase, that after the inference phase, every time you use it, it learns from you and it keeps improving the model. But no, this is not how it works. It doesn't keep improving, it's the same exact model it was a month ago. It's just that it uses this data to train for another model. For example, now we have Opus 5, so from Opus 4.8 we have gone to Opus 5. And maybe we will see a new Fable 5 model, like 5.2. Or maybe they release a new one that maybe they name it Mar, and they call it Mar 2. Or change, if the gap is bigger, then they change the name. If the gap is not too different from the initial model, they then just change the number. So, talking to the model, as I said, does not teach us. As we can see in this Claude, he is sad because it doesn't learn from it, but then from this, it can create another one that it learns. Now, the most important two parts is the training and the inference. Training, it only happens once, at the beginning, the first phase. It's slow, and as we said, it costs millions. It is the most expensive phase and the most longer. And it adjusts billions of weight just to then frozen it and release it to the public. That is the inference phase, that every use, you can use it every day, every single moment, anyone can use it, is fast and cheap, you just have to pay for a subscription, or if it's a free model, then you can use it. But the important thing that you have to remember is that it teaches the model nothing, as we talked about it earlier. And I hope that you keep that in mind, because that is the number one mistake people make. Then we have the knowledge cutoff, that it's like a vocabulary inside of AI. That, as you can see in this graphic thing, we have the data training and the data training that the data and must be given new phrase data. Like the data training that it ended in the training phase was all the data, like the training data ended, it's when the training phase ended. So you cannot ask, it doesn't know about how is today's weather, what temperature is right now, how it was yesterday, how it was last week. It doesn't know anything of that because all the data it had, now it's not being trained because the training phase has ended when you are already using a model, because you are in the inference phase. So we must give it like real data, actual data. So that's when they give it phrase data every day, like they put an extension or something inside Claude or ChatGPT. But most use cases now they use the web search tool. So to get that phrase data, they have inside a web search tool that you can see it when you ask Claude in a chat about, tell it to search anything in the internet, you can see that it's using, it appears web search tool. So it's using that web search tool to have actual data from today, yesterday, last week, and search anything online in the exact moment. So it's not, it doesn't just have the data it has been trained of. So it has this phrase actualized data. Then we're talking about the myth of AI, that AI understands, but it's not how it works. You ask it a question, you give it a prompt, you send it a message to Claude in here, and it finishes the most likely sentence. Word wide brute is what we talk about, that it predicts. It does not understand. It just predicts the next word. So to understand it, let's put like an example. It doesn't just it does not comprehend, it just uses patterns. It predicts the next word and the patterns that it has from the millions of data that it has been trained of. So from all this data that it's huge, if you could see the amount, it's huge, it's so huge. Then from all the data, it analyzes the patterns, it finds all the patterns and everything, and then it predicts the word, it predicts what you are going to say and what it says word by word. So if you ask it, for example, because it doesn't understand, it just like this. In this example, if we ask Cloud Code, for example, what is the capital of France? It can respond to us that it's Paris, and it's correct. But this knows it from the all the data that it has been trained, and it has recognized that the capital of France is Paris from all the patterns that it has from the data. But it doesn't understand because it has not been to France, because it doesn't know about geography, and it just follows the patterns. And this is the most likely response from what's the capital of France. If the most likely response was Barcelona, then it would have said Barcelona. That's why it predicts, because it's the most likely response. And this, as is a general question, it knows it for sure. But if you ask it for a concrete book that it's in a language that it's not speaking around the world, and it's not even in the internet, then it just might have like a few phrases, and it will invent, like hallucinate word for word what is the most likely response. For example, if you ask it about the plot and it does just have 2 lines of data about that, it just will go like word per word following the pattern, what is the most likely word it will come next. And maybe that plot, it has some things true and some things that it has hallucinated on. But in this example, as it has all the necessary data, this cannot happen. Then we have the difference between fluent and correct. What fluency proves is that it has a plausible, it sounds good word pattern, and you may think like it's correct all the time because it tells you in the language that it seems like he's always telling the truth, he's always right. But that is not what happens, because fluent doesn't equal correct. Because what it doesn't mean fluency is that the claim is true. It's just that it sounds plausible, not that it's true. That it understands the topic, it doesn't mean that, because as we saw, it may not understand what geography is, but it gives us this response as if it know it. And this doesn't mean that you can skip the check and not check for yourself. For basic data that each have a ton, maybe you don't have to check, but if you are using it for your business or for concrete data, it's recommended to check before, just a quick check, so to see if it was correct or if it hallucinated. That it doesn't mean that it lied, because lying implies knowing the truth, because if it doesn't know the truth, then it hallucinates. It likes invent what could be the best predictor, like the most likely response, because they cannot tell you I don't know, like a person would, because persons mistake a lot of times, and we also say I don't know it, I don't get it, I don't know it, I don't have the answer. And you probably have never heard an AI respond to you saying I don't know, because you may pay, or all these models want to be the best ones, and they cannot tell you that I don't know. If you have paid for 100 Pro Max or any subscription, they just do this, that it's hallucination. They predict the next word, and maybe they are right or they are wrong. So that's why you have to check or give it the enough context so that it only uses that context, and this way it cannot hallucinate. Or you put a skill that it can tell you if it doesn't know before hallucinating, and all this stuff. So now that we have gone through all the concepts of and what AI is, the vocabulary that you need, through every phase it goes, now how can we use it? How can we use Claude, ChatGPT, Gemini, Kimi, all these new models, all these apps, and then we have the models as we talk about it, like Sonnet 5, ChatGPT 5.6. So we have to use them correctly, because you can just put 3 words and hope that it does the thing that you have in mind. No, this is not how it works. First we'll go through the basics of a good prompt. So here we have it. An anatomy of a good prompt. It has to have these 4 things. The role, that for example, if you give it the who it is, like who is, what is going to act from who. For example, you are a senior growth marketer specializing in B2B SaaS retention. You are a design expert in this field, like the role, who it is. Then you give it the task, what it needs to do. For example, write 3 emails on wording sequence design to educate new users on core features and reduce early churn. The more complex, the better you explain it, the better the output. So the task, for example, create a website for this, or help me find leads in here, or help me stay up to date about AI and write me an email, whatever. Then we have the context, that it's the data it needs, whether you have your second brain connected or not. For example, in this example we are launching a new tier for our project management app aimed at solo entrepreneurs. But our churn rate in the first 30 days is currently at 12%. So it's the context, the information it needs. If you ask it about your business, you must give it information about your business, because if not, it won't know who you are, what you do, and it will do it generally, but we want specific results for ourselves and for our projects or businesses. And the fourth part is the format. How do we want this? We want to send us an email, we want a PDF or just plain text, we want a table with rows and everything. How do we want it? An HTML file, for example, if we want a website. So in this case, output the response as a markdown table with columns for email, timing, days, post sign up, subject line, and core message body outline. So we have these 4 things: role, task, context, and format. With all these 4 things of a good prompt, The difference between a good prompt and a vague and a specific, if we follow this anatomy of a good prompt, if we don't follow it, we will get a vague response, a vague output from Claude or the LLM we are using. And we will tell it, for example, make it better without a role, without a format, without these four things. It's missing some of them, for example, a task, the role, or maybe the context, and it gives us random results that we do not want. And we just give a simple, super simple prompt, and we hope that he is so smart that it can read our minds. But this is not how it works. We have to give it this anatomy of a good prompt and give it the enough context and everything, so we have a specific result, and we see this amazing Cloud Code mascot in here. For example, you are an editor, specialized in what? You give it one clear task with the format that you want, and it lands it near done, almost perfect, or if it has done it in the first try, then amazing. If not, you tell it, you give it feedback, you did improve this, I wanted this, and save this so it doesn't happen again, and maybe create a skill so it knows how to do it, and keep improving in a self-improvement loop. So every time you get better results, not getting the baked response with random results that we do not want. Now we'll look at zero shots versus a few shots. That it's a vocabulary inside the AI industry, inside the AI niche. For example, zero shots is when you not put examples. There are no examples in your prompt. In the anatomy of a prompt, you haven't added any examples. You just describe the goal and use maybe the role, the context, and everything we talk about, the four things in the anatomy of a prompt, but you do not give it an example. And it's faster, but most times it's even enough. You don't have to give it examples in every single prompt. But there are some use cases, because maybe you want it to do a task but I'm not sure how to do it, and then you have to do the few shots that you have to paste 2 or 3 examples more or less. So now it writes more like those examples and it can learn from them, so it knows the styles that you want and the tone, because it gets it from those examples. Because as you have put the examples, it knows that you want a similar result as those 2 or 3 examples. And this happens when you want it to perform a task and don't know how to describe it. So the best thing is putting examples, 2 or 3 more or less. It's called few shot. On not putting any, it's zero shot. Then why does examples matter? Because when you put an example, you show the input and the output to the large language model. Then when you put a second one, the model continues the pattern. It analyzes the input and the output and how it is that example. So it has 2 or 3 and it knows more or less how you want it. So it combines, it gets the information from all those 3 to create your own output. So a good example carries the style, the length, and the structure that you want. It teaches Claude these 3 things. Then we have the section about being specific. It's important to be specific, because if you are not specific, it's detail you do not specify. Claude, for example, or the large language model, like in this image, it doesn't know what it has to find, so it just stays there. It takes a lot of time, it costs you more money, more tokens, and it has to be guessing, because it thinks, well, he didn't tell me what really wanted, it's like too general, so I have to guess from which direction I have to specify. It might be this, that, but it's not focused on doing it right away. Now it's focused on guessing, on knowing what more or less you wanted to say and didn't actually say it in the prompt. So it takes a lot of more time and tokens, so it costs you more. Then each detail you specify, is one the model no longer has to guess. As we can see in the second image, this one is focused on the task that you have given it. It knows for sure what it has to do, so it goes there and it starts right there. So it knows what it has to find, what it has to look, what it has to do, the output it has to give you, and it's much more faster. It doesn't waste tokens that didn't need to be wasted, and you have a better result because you have specified what you wanted. Because without specifying, you get a more general or a specification that maybe it was not the one that you had in mind. So instead of trying the AI, instead of giving the AI a prompt so it guesses, make that it cannot guess, because you have written a so well written prompt that it cannot guess. So for this, like in writing, in typing, it takes a lot of more time than just via voice. That's why I have like a Keak that it chooses a whole AI voice assistant and a whole ecosystem app, but it has a thing inside it that you just hold two keys and talk, and it writes for you in exactly what you said, with commas, with punctuation marks and everything. And the names, it can write them, you can add vocabulary and everything. And you can also talk in English and it writes in Spanish. So I use that instead of typing because I go faster, I explain myself better. So if you want to use it, it's totally free. You have unlimited dictations, transcriptions, anything. You just go to keak.app, download the app, and that's it. You go there and you will find how to, you install it in just 5 minutes, and you hold the keys and it transcribes for you in any windows of the computer. And it also has an iOS app that in Apple Store you just search Keak, and it has a keyboard where you dictate and it transcribes for you. So it's the exact same thing from the laptop to your mobile phone. So these are some things worth specifying, that, as we said, we need to be specific about it, but these are the things that you need to specify. These are the important ones. For example, the first one is the length. If you want 3,300 words, 500 words, how much do you want it? 2 pages, 10 pages, a whole website, just a page of the website, whatever length you want, you have to specify it. Then we have the audience. Is it for a 10-year-old boy, or is it for older people, for people in their mid-20s? So you need to specify for who is it for. Then we have the tone. We want it in an angry tone, like this little Claude mascot. We want it in a formal style, in a casual style, whatever tone you want. Then you need to put the constraints. This is a very important part, because inside Claude, in their website where they say how to use better their models, they put a lot in example prompts about things. They put not a lot. They put do not do this, do not do that, do not do these things. So it's important to tell it what it does not have to do, the constraints. Do not search in this website, do not add images, do not make it more than this, do not put names or important information that people shouldn't see about it, like my phone number, what it does not have to do, the constraints. And then the last thing, what it can exclude, what to exclude. Like, do not put this, do not look at this part in my second brain, do not talk about this topic inside it, instead talk about this. So with these 5 things, these are the most important things you need to be specific about to get the best results. And with that, we have gone through all the masterclass of about AI, as you can see here. I hope you like it, you enjoy it, and please give it a like and subscribe, because it took me a lot of time to prepare this, film it and edit it, so it will help me a lot. And if you want me to make another video about this topic or a different one, just tell me in the comments and I will be glad to do it. So thanks for everything, and I will see you in the next video.
That's how I build, one person and every AI in public, the AI that matters, every day.